The other big use case we're starting to see where Cato can be woven in to help with this evolution and adoption for SASE over time is mobility. So we see a lot of VPN replacement projects. The old legacy VPN was sort of an on-off. If you had credentials, you were authenticated in, and now you have access to the entire corporate network. As we've seen from some of the more high-profile data breaches, that's a horrible idea. You have to best practices to do microsegmentation within the network, so that if an entity or a work group is given authentication into the corporate network via VPN, they're able to, the IT is able to truncate where they can go once they're on the corporate network. So an IoT device is mapped to other IoT devices, and that's the extent of where they can go once they're on the network. These users are a third-party contractor, and they're allowed to go here, but not everywhere. So that is part of a zero-trust network access architecture, and part of a new VPN replacement strategy called SDP, or software-defined perimeter. And it's the idea that we're able to address those mobile and remote and, in some cases, temporary VPN users differently than in the old manner. In the old legacy VPN as well, it was typically tying those remote workers using public internet at McDonald's or whatever, public Wi-Fi, to a physical appliance somewhere. So a user in Singapore would be hairpinned all the way back to a VPN concentrator in Dallas, for example, creating an experience that connects them, but not optimally. So with an architecture like SASE and what Cato delivers, we would connect that user in Singapore to a POP in Singapore, encrypt the tunnel, and then ingest all that traffic into our backbone, and they're able to ride Hyperloop style from far end to far end to get to AWS or whatever.
POP to POP, basically.
That's exactly right.
To the nearest POP to the end user, right?